I can't believe I was almost late for my own live stream. Where's my coffee? Like, I couldn't find my hat, and like, what am I going to do? Am I going to go on like without a hat? So I got this hat. So that's what we got here, and I've got notes this time, so we're going to be like right on the money. So I got to bring up make slurpy noises. I got to hello, 4 people. I see people. Hang on, we got a little bit of a technical difficulty here. Please hold. Okay, so we are going to be working on this math problem / puzzle. So let's see. I've still got to bring up the I got to bring up the whiteboard. Oy vey, Gavelta. Okay, and I will create a new board here. Okay. So while I'm doing that, say hi in the chat. Talk amongst yourselves and let me know where you're from. So let everybody else know where you're from. So we can do that. Okay, share screen, and yeah. Okay, Chrome tab, and there we go. And share. It's nice to share. Here we are. Okay, gotta shut that off. Alrighty, so let's do something here. Hang on here. Get my act together. Alrighty. So what are we looking at? We are wanting to find, I believe it's 6 zeros for this function. 3 cosine x minus 4 cosine cubed x plus sine of 2x. Okay, so any thoughts? Feel free to put them in the comments. If not, I'm just going to start powering away into this. Hang on here. A little bit more technical stuff. Technical. Okay. All right. Okay, so first question here is, we want to factor this, and we've got 2 cosines and a sine, but it's not just a regular sine, it's a sine of 2x. So what are we going to deal? What are we going to do with that? Well, ideally, we want to have all the same functions, eh? So we will switch. I mean, we could try switching everything to sine, but why do that when we've got mostly cosines? So let's do something with this one here. So let's change that to 2 times the sine of x times the cosine of x. Okay, now we can factor out the cosine x. cosine of x. Factor that out, we get a 3 here, minus 4 cosine squared x plus 2 sine, no, sorry, not sine x. What are we factoring out here? Hello, 2 sine x. Yeah, actually, that is right. That is right. Which makes it look messier. There's another step here. I forgot. It's actually a little bit worse than I thought. Yeah, so we factored that out, and now we've made it look a little bit worse. But we have another identity which we can use to convert this. So actually, yeah, we are going to end up converting everything into sines. So the next trick is, how can we convert all of this into a sine that we can work with? And yes, I've got my notes here. So we'll keep that cosine x and all the stuff here. And this 3, we're going to convert it into a -1 plus 4. Okay. And then we've still got -4 cosine squared x plus 2 sine x. Okay. And then what can we do with this 4 minus 4 cosine x? We're going to factor out the 4. And we end up with 1 minus cosine squared x. And what's next? Here's an identity which hopefully you're familiar with. That 1 minus cosine squared x, that ends up just being sine squared x. So yeah, ultimately we did want to, I led you all astray. Ultimately, we did want to convert everything to sine, but in order to do that, we have to factor out the cosine. So let's scroll this up here. We gain some valuable real estate. Okay. And let's write out what we've got so far. So we've got the cosine of x times -1 plus 4 times the sine squared of x plus 2 times the sine of x. Okay, so now we've got one of our factors, and now we've got a quadratic. So this next part should be fairly smooth sailing because we're rolling into quadraticville. Personally, I like to make it a little bit easier on myself. By just focusing on the quadratic in the brackets and making this little substitution, u equals sine of x. Okay, so now I leave cosine aside for a bit, and let's just rewrite this in the order that we usually like to see quadratics. So we'll have 4 u squared. Okay, that's that bit, plus 2u minus 1. And now we can use our favorite method to factorize that. And let's just, what is your favorite method? How do you like to solve quadratics? What do you say? We have a bit of a hint here because I've suggested that this might be easily factorable. So let's do this, or not. Hey, we could just do complete the square or what have you. What did I do in my notes here? Yeah, I use the quadratic formula. What a cop out. Okay, I'm going to do that here too. Okay, so here's our A, here's our B, and here's our C. So what do we got? So we got negative B plus or minus square root of b squared minus 4ac all over 2a. And of course, that's our u is going to be that. So that we end up with -2 plus or minus square root of 2 squared minus 4 times a is 4 and c is -1. And that's all over 2 times 4. Alrighty, so -2 plus or minus, what do we got here? 4 minus is going to be 4 plus 16 all over 2 times 4. I'm not going to multiply this out because I know it's coming. Let's scroll that up. And this, I'm not going to write out this whole thing again. This whole business, let's just cross that out. That ends up being 20, which equals 4 times 5. Okay? I hope that didn't go too crazy with that. So we end up with -2 plus or minus, let's bring the 4 out of the square root, 2 root 5 all over 2 times 4. Now you can see why I didn't multiply that out. And this is something I like to say. Don't multiply stuff to get careful about multiplying stuff when you're factoring, which is pretty much what we're doing, because often what happens is then you have to end up factoring out what you just multiplied. And the way I say it, if you don't like raisins in your cookies, don't put them in the dough and pick them out later. Just don't put them in the first place. So we can get rid of this 2, and that becomes -1. Get rid of that 2, and it becomes an invisible 1 here, and get rid of that 2. And we end up with -1 plus or minus square root of 5 all over 4. Okay, and this might ring a bell, particularly if there's a 2 down there. You might recognize that as the golden ratio, and that is going to lead us into the next part of our program. See, I'm Dad, just so you know, but don't call me that. All right, so where are we at here? So we've got our u, which what's u? So that's our sine of the thing here. So let's scroll up here. So the sine of x equals -1 plus or minus square root of 5 all over 4. Now, the next move here, I mean, because remember I said that we could figure out what the exact values here of the zeros were. So we now know what the sine of x is, okay? But how do we find out the x that goes with this bizarre looking contraption? And if you've done like special triangles in pre-calculus, you've probably done like where you get this, for example, that's 45 degrees, and that's square root of 2 over 2, and that's the square root of 2 over 2, and that's 1. And so you go, oh, look, the sine of 45 degrees is equal to square root of 2 over 2. Okay, and then what's the other one that you see here? You get a 30, 60, 90 triangle. Okay, what we're going to work with here is a lesser well-known. At least I haven't seen it with pre-calculus students that I've worked with. I haven't seen the use of the golden triangle, so we're going to look at that now. And I do have another video which I will link at some point, which I actually posted yesterday, which goes through this triangle in a lot more detail. But let's do this right here. Otherwise, what I'm going to do here might seem like a little bit hand wavy, like you're going to go, where'd you get those angles? So if you check out that video, and I'll post a link in the description or someplace pretty soon here, it shows you how we even got this in the first place. So yeah, I apologize that this might seem a little bit hand wavy here if you haven't seen it before, but this is another special triangle. And the thing is, if we bisect this angle right here, so now this angle here is 72 degrees, but these little bit angles here are 36 degrees each. Okay, which means that we have got two similar triangles, this long standy-uppy triangle and this lying down triangle, because this is 36 degrees here, this is going to be 72 degrees, and if when you're dealing with similar triangles, the angles are absolute, okay? We don't know what size, we don't know what scale we're dealing with, but we've got 72, 72, 36. That's our triangle. Okay. And so we've got two of them, so they're going to have, their proportions are going to be the same. So they're similar triangles. And this is what's going to save us here. So what we do is, when we're dealing with proportions, we have the luxury of choosing what our unit is going to be. So out of convenience, we're going to choose this base right here, and I'm going to change the color of it just to maybe make these things really clear. So this right here is going to be our unit, but this also is a unit, and this also is a unit. So I'll write that all out in red too, or orange, whatever color this is. So 1, 1, and 1. Okay, so that's our unit. What we're left with is, and let's make that green, is this mystery amount, which is X. And this other side, we've got an isosceles triangle, so this is X plus 1. And so now we're going to solve for the sides of this triangle. And remember, all we can do when we're dealing with the sides is proportions. And so that's what we're going to get. So we've got this triangle right here with the two ones at the side and the X at the bottom. Okay. And so we're going to say that its side is to its bottom, the same as this big triangle here. Its side, which is X plus 1, is to its bottom, which is 1. Hello, a shout out. Augustin, okay. Valverde Ramos, thanks for joining us. Look at that. You know what? Because you put a thing here, I'm going to click on your comment and have it come up there. Look at that. Oh, Beryl, I'm putting you up now. Woohoo! Thank you so much. You know what? Okay, it's a thing. I really appreciate the feedback. Okay, so thank you so much for letting me know that I'm not just talking into a little green light on my screen. So hey, so where are y'all from? What part of the planet? This is the audience participation part. Well, I have my dad coffee. Okay, so let's solve for X here. So I'm going to go back into this. Okay, so what do we got here? Those are both ones, hey? So this is equal, so we got 1 times 1 is going to be equal to X times X plus 1. Okay, so I'm just going to rewrite that over here, but I'll work this all out. X squared plus X equals 1. And again, you pick your favorite way of handling this, but we want to solve for x. Okay, and we'll do a completing of the square here. So we've got this middle, okay, 1. The middle coefficient is 1, so we need to take a half of that, okay, which is a half, and square it. And so that completes. We've got a square on this side. We better add that 1/2 squared to this side too to keep our equality. So just 1 plus 4, 1 plus a quarter. So on the right side, we've got 5/4. And on this side, we've got x plus a half. And that's all squared. Okay. So now we'll square root everything, eh? Square root, square root, square root, square root. And scroll that up. Okay, so we end up here with x plus 1/2 equals square root of 5 over square root of 4, which is 2. And now let's shoot that on over here. And we get x equals negative 1/2 plus or minus square root of 5 over 2. Okay, but we're dealing with proportions of a triangle. Okay, so we're just going to keep the positive value. Okay, so in this case, then our x equals negative 1/2 plus square root of 5 over 2. Okay, so that's our x. Okay, so you're going to go, well, yeah, where does that get us? So let's redo this triangle up here. Okay. Actually, what we're going to do here is just be really careful here. We're going to do this triangle here on the bottom. Okay, so it's going to be slightly different, but it's the same triangle, same proportions. I'll draw it out here for you so it'll all make sense here. Okay, so now here we've got the sides are 1. Okay, because this is gonna end up being the hypotenuse of a right triangle, these ones. That's why I wanted to do it this way. And we'll cut this in half. So you see, this is still a special triangle, but it's a more complex special triangle. And I think it's important to look at stuff like this because it's really easy with a couple of examples that I've seen in like the high school pre-calc where you do the 30, 60, 90 triangles and the 45, 45, 90 triangles. Get the feeling that they're special in that, oh, hey, there's a trick to figuring out some trigonometry. But the point is, all of trigonometry is geometry. This is one step, just one step more to it is all it is. So we've got that's x, okay? But remember, this is 72 degrees, and we don't know what that side is, but that's 1. This here, remember, this was 36, so that's 18 degrees, and this side here is x. So this side here, which I'll mark in red, is half of this. Back here. It's half of this. So what is that? That's a half of negative a half plus square root of 5 over 4. So that's going to be negative 1 plus square root of 5 over 2, but it's a half of that, so it's going to be over 4. And have we seen that someplace? Oh my goodness, yes, we saw that way back up previously. So what do we got here? We've got 18 degrees here. So that means that the sine of 18 degrees is equal to this half x over 1, which is negative 1 plus square root of 5 over 4. Huh. Also, that's also the cosine of 72. because cosine just means complementary sine. It's the sine of the complement of the angle. So we could have also said cosine of 72. But the thing is, we're interested in what sine is this. Okay, so now what do we got here? What do we got? We've got, going back to our original, and you know, we're just about there. We are just about there. And I will write this up and post it eventually. If you come back, I'll pin it to the comment or something like that, so you can see all this in one little, all in one little chunk. Okay, and I'm also going to, but I'll also post for a day or two this whiteboard here, so you can come and look at it on your own. So what did we have here? We've got the cosine of x. This is our factored thing. Okay, times a quadratic, and what was that quadratic? It was okay, scroll. Okay, -2 plus or minus -1 plus or minus the square root of 5 over 4. So that's a little bit harder to see, and do forgive me because I think I'm reusing the x a couple of times. Okay, so we got, this is plus, and we'll call that we'll say plus this thing. Usually use phi or phi bar or something like that for this, but I'll just write it all out. Plus -1 plus square root of 5 over 4. And actually that should be minus because we're doing, and x minus -1. No, I'm messing up. Should that be plus or minus? Okay. Yeah. The whole point is it's sine 18. I'm getting a little bit screwed up here. I'm going to have to, because I've already got that over 4. I think maybe that should be plus. I'm not sure. I got lost. Yeah. So what I've done is I've done the hardest part, and then I've lost my way here. So let's go back to the questions of what is the what are the factors of this. So cosine x. There's two. What are the zeros? There are two places when this is 0. Yeah, and here's the problem. Here is I've got this x. I'm using it for two. I'm giving it two meanings, and that's really bad. So cosine x equals 0. So what two values for x give a cosine of 0? Well, so x can be pi by 2 or 3 pi by 2. So, and that was the first one. We could have gotten that right at the beginning. Okay. And now let's oh, look at this. Oh, we've got Turkey and Spain and Kandahan. Hello. You're gonna love geometry. Thank you. I'm glad. Appreciate that. Okay. So what's our next bit here is this bit. So this ended up being the sine of 18 did this one. Okay, I've just gone and made it more confusing here. Okay, so and I apologize for this. I don't think I'm going to be able to fix it right now. Is I'm giving x two meanings. Okay, so this is one, and another solution, of course, is 18 degrees, okay? Because the sine of 18 degrees, I'm really mixing this up because I'm doing pi by 2 here, 3 by pi by 2 here, and 18 degrees here. So, you know what? Here's what I'm going to say. Let's go. I think we've done enough algebra and stuff. Let's just go and take a look at, see what this looks like on Desmos. So give me a moment, talk amongst yourselves. I'm going to put this up on Desmos so we can actually see what it looks like. Okay, so what do we got here? We've got three. Here, I'll share this with you so you can see what I'm doing here. What am I doing? So stop the share. Hello. So I'm going to let you see. We're going to finish off on Desmos here. Share screen, and Chrome tab, and there's Desmos. Yeah. Okay, so 3 cosine x. What are you guys all studying? Where are you at in school? Like, are you calculus, pre-calc, high school, engineering, university? What are you hoping to get out of all this? Because that helps me know too what to put up on these things. 3 cosine x. Let's see here. How come that's not working? Oh yeah, it doesn't like that cubed there. Okay, so there's our. Okay, so let's set this so that it's we're dealing with pi. Okay. Okay. So now and we could change it over to degrees in a bit here because we've kind of mixed up. And what did I say? Let's find it between 0 and 2 pi. So that's over here. Okay. So now I hope this is up. You guys can see this, right? Yeah. Okay. Great. Beautiful. Okay. So let's look at this. What did we say? So pi by 2 and 3 pi by 2 should be on here. So there it is. Oh, there's pi by 10. There's pi by 2. Okay, there's your pi by 2. And 9 pi by 10. 13 pi by 10. There's your 3 pi by 2. Okay, so these two are here because of the cosine. Okay, we factor out the cosine, we're gonna lose these two. So let's just do that really quickly here. So what did we have here? So we've got 3 minus 4 cosine x squared. Okay, and then this was plus 2 sine x cosine x. So now this just becomes 2 sine x. Okay. So this is what I was meaning to say here. See, these points here, these are due to the cosine x being the factor. There's your pi by 2, and there's your 3 pi by 2. And then this new function where I factored out the cosine x, it keeps these other, I think it's 4 factors, isn't it? Yeah. And these are our, see, what's pi by 10? Okay, pi is 180 degrees. So pi by 10, that's your 18 degrees. Okay, what's your 9 pi by 10? Well, that's your minus 18 degrees. Okay, and here, and then we got a couple of others here as well. Okay, so I'll leave you to kind of work out what those are in degrees. That's all I have to say about this. I hope that this was helpful to you. Something I'm going to do right now here is I'm going to post this here. So be good, because I'm posting this where I'm not monitoring it at all. So I'll post this for a day or two so you can go and look at the notes. Okay, and you can go see what I've done. And I'll admit that some of it got kind of muddled at the end, and I apologize for that. Let's see what we got here. High schooler here. Stuff. Okay, and like Trigon Analysis. Awesome. Teaching yourself calculus. That sounds like fun. Oh, there you are. Do you have do you have somebody working through that with you? You got a textbook? How are you doing that? I'm curious to know. And I think I've responded to all the other comments. So that's good to know. So if you have any questions, this is the time to do them because I'm going to be signing off. And you know where to find me for more. My goal is to do something like this every Sunday. Mostly textbooks, online lectures like yours. Yeah, that's so awesome that you can check out online lectures. Like MIT has got some good ones. I think what was his name, Gilbert Strang. He does. I know he does linear algebra as well as I think he's got some calculus on there too. And then of course Khan Academy. Man, you could do like a whole bunch of calculus in Khan Academy. So yeah, it's just amazing what's out there that you've got. So that's awesome. Okay, so I'm gonna roll. Go ahead and check out that Miro.com, but understand that you can actually modify that if you want to. So please be good about that. And so I'll keep that up for a day or two, and I'm going to bid you adieu. So thank you. One other thing before I go, I do have a book on Amazon, and it's going to be different links depending on what country you're in. Okay, but if you go and say, you go look up this SOHCAHTOA, Ravings of a Quarantined Mathematician. It's free today on Amazon on Kindle. So grab yourself a copy. It won't cost you anything. Okay, awesome. Thank you, folks. Yes, you have a nice day, and I'm gonna head out. Cheers. Thank you so much, and take care. Bye-bye.